Okay, so now let us look at the code for how to delete an element in the list using a dynamic array implementation. Now for insertion, we kind of shifted elements to the right, starting from the right, so from the end of array. Now in the case of deletion, we have to kind of shift things to the left. So for example, you want to delete an element at index 0, so that means you have to shift things to the left. So overwrite 10 with the element to its right. So 23 kind of copied to the left, and then 13 copied to the left. So that means 23 will be overwritten with 13. Then 17 copied to the left. So 13 will be overwritten with 17, and so on. Then 21 will be copied to the left. So 21 is going to be still here. Okay, so but we have to also decrement end of array by 1, because the logically accessible portion of the array is now from index 0 to end of array minus 1, because the size of the list has been reduced by 1. So that's what we do here. We run a for loop from insert index equals delete index, from starting from where you want to delete. So if you want to delete from at index 0, that's the delete index, and index less than end of array, and basically copy the value of the element at index plus 1 to the value at index, and keep doing that until index is equal to end of array by the time you come out of the loop, and then set end of array minus minus. Now you can also kind of modify the value of an element in the list by calling the modify element function, and just all you have to do is array of index equals the data that you want to modify. Now you can count the list, means you want to count the number of elements in the list. So run a for loop from index 0 to index less than or equal to end of array. Remember, there is an element at the index end of array also. Now you can keep incrementing this count variable, which is initialized to 0, and then once you're done with the loop, you can come back and return count. Now this implementation of count list is going to take state of n time, because you have to basically scan through the array. Now you can find the number of elements in the list in state of 1 time by just returning what? End of array plus 1, because end of array is the index of the last element in the list, and indexing starts from 0. So you can just say end of array plus 1 is the size of the list. Okay. Now the insert operation that we saw in the other video will take big of n time complexity, because you have to, at the worst case, copy the contents of the elements in the previous list element by element to the new array, as well as if you want to insert in the beginning of the list, you have to kind of copy the content to the right, and that would, you have to do that n time if you have to really insert at the beginning of the list. We have to do this shifting or copying to the right all the way up to the end of array. Similarly, delete operation will also require you to do big O of n time. Again, it's big O of n because even in the insertion, if you want to insert at the end, you can just do in one operation. That is not n shift operations. Similarly, if you want to delete at the end of the array, you can just do end of array minus minus. So you won't even go inside the for loop, because if you want to delete at end of array, index equals end of array, index less than end of array, no, you come out of the loop and just do end of array minus minus. So that's why delete operation could be done with just one end of array minus minus operation. That's the best case. At the worst case, you have to do this shifting to the left n time. So that is big O of n time complexity. Now, if you want to really do these things, now create an object of class list. So this is how we do this. Now remember, this is using a dynamic array based implementation, so you have to create an array. So 1 is the kind of minimum size that you could create, and every time you insert, if you insert more than what is the space available, you end up doubling the size of the array and then do the insertion. Of course, the insert function that you call here will take care of that, because inside insert function, so this is the main function. So in the list class you have the insert function, and there you also have the resize function that will take care of doubling the list. So we saw the kind of trade-off between implementing the insert operation itself. We saw like why it's better to double rather than do increment by 1. But you see, still the requirement is you need to have space, consecutive block of memory available. So this is okay if your list size is small, but if your list size is larger, okay, then you need that much consecutive block of memory, which cannot be guaranteed, and especially if you're doing the resizing operation, not guaranteed. Now, in addition, if you're storing what you're storing in the list is also important. If you're storing an object of a very large size, okay, so let us say you're having an employee class, and each employee object will require say 40 bytes of memory. Instead of 4 bytes for an integer, you need 40 bytes now. So if you're really storing a large list of employee objects, so then you really need that much consecutive block of memory, which again cannot be guaranteed, that many bytes. Okay, so that is why we are going to look at another implementation of a list ADT, which is a linked list based implementation, and it's one of the very well known in the sense it's a commonly used data structure. It can be and throughout this course at several times we will be using the linked list data structure. Okay, so that's the motivation for the linked list. So we'll stop with this and we'll start with linked list in another video.